Welcome, Mr. Sutton here with the AB Calculus 311 Extra Practice Number 2 solutions on derivatives of logarithmic functions. For this problem, to find the derivative, I'm going to need to use the chain rule. So I have log base 5 of something. That's going to be 1 over the something, sine of x, times ln of 5. And now I have to multiply this whole thing by the derivative of the something, derivative of sine, which is cosine. Since I only have a 1 to begin with up here in the numerator, 1 times the cosine, I can just put that in the numerator as cosine of x, and this one's done. Or, alternatively, if I wanted to, I guess I could write this as cotan over ln of 5 if I simplify these trig functions. To take the derivative of this expression, I'm going to use the log rules first, and then I'll take a derivative. So since this is really x to the 1/2, I can pop that exponent out as a coefficient in front of log base 5. So I'll rewrite this as 1/2 log base 5 of just regular x. And now this is going to be 1/2 times 1 over x times the ln of 5. So 1 over 2x ln of 5, which is as good as it's going to get. To take the derivative on this problem, since I have an x in the base and the exponent, I need to differentiate logarithmically. So let me start by taking ln of both sides. Ln of y equals, I'll have sine of x times ln of x. Taking the implicit derivative now, I have 1 over y times dy over dx on the left. On the right side, I'm going to use the product rule. So setting up my box and ribbon, I've got sine of x and ln of x, whose derivatives are cosine of x and 1 over x. Using the ribbon to put it back together, this is going to be cosine of x ln of x plus sine of x over x, or sine of x times 1 over x, either way. Now I have to get dy over dx by itself, so I'll multiply both sides by y. And instead of writing y times all this stuff, since I have to do my derivative in terms of only x, I'll replace y with the original here, x to the sine of x. And we're done. To take the derivative on this problem, there's a few ways you could do this. One thing you could have done is split this up into ln of 9 plus ln of x to the 7th, and then simplified things from there. But it's not that bad to just use the chain rule on this. So this is going to be 1 over 9x to the 7th times the derivative of 9x to the 7th, which is 63x to the 6th. And then if you want to reduce that, you can. This becomes 7 over x if you reduce the x's. To take the derivative on this problem, I'm going to start by just popping this 2 out as a coefficient using my pop-out rule of logs. And now the derivative of this is just going to be 2 times 1 over x, or 2 over x. To take the derivative on this problem, since I have variables in both the base and the exponent that I can't simplify away, I need to use logarithmic differentiation. I'll start by taking the ln of both sides. So we have ln of y equals, and now I'll use my pop-out rule, x to the 7th times the ln of 3x. So differentiating implicitly, on the left side I have 1 over y, dy over dx. On the right side I need a product rule here. So I've got x to the 7th as one factor, ln of 3x as the other. And now their derivatives, which are 7x to the 6th, and this is going to be 1 over 3x times a tail of 3. So that just reduces to 1 over x. Using the ribbon to put it back together, I've got 7x to the 6th times ln of 3x plus x to the 7th over x, which I can just simplify to x to the 6th. Now let me go ahead and multiply both sides by y so I can get dy over dx by itself. And since they want the derivative in terms of only x, they said in the directions, I'm going to replace this y with the original function, 3x to the x minus 7. To take the derivative on this problem, I'm going to start by using my log rules. This is really x to the negative 1 inside here, so I'm going to pop out that exponent as a negative in front of the log, and I can now write negative log base 2 of just x. So this is just going to be, using our log derivative rule, negative 1 over x times the ln of 2 in the denominator, and this is done. To take the derivative of this problem, I'm going to need some chain rule. So the outer function here, we have something to the 5th. That's going to be 5 times all of this stuff to the 4th times the derivative of log base 3 of 2x squared. So probably the fastest way to do this is just take the derivative of log base 3 of something. I mean, we could split this up using log rules, but that seems like even more work. So this is going to end up being 1 over the something, so 1 over 2x squared, times the ln of the base, ln of 3. And now I have to multiply by the derivative of 2x squared itself, which is just 4x. And yeah, I'm not going to bother simplifying that. To take the derivative on this problem, I need to use the chain rule. My outermost function is I have something to the second power. That's what this means. We have sine of all this stuff being squared. So I'm going to have 2 times the something to the first power. So 2 times sine of ln of x. That's the outer derivative. Now I need to multiply by the derivative of sine of ln of x. Well, that's going to be cosine of ln of x times the derivative of ln of x itself. So that's going to be 1 over x out there. And we're done. To find the derivative on this problem, I need a chain rule. So I'm going to start by doing the ln of something, which in this case is going to be 1 over the ln of 7x to the 6th. Now I need to multiply by the derivative of ln 7x to the 6th. So that's going to be 1 over 7x to the 6th. Times, now I need the derivative of 7x to the 6th itself, which is going to be 42, x to the 5th. And I'm not going to bother simplifying that, so let's just call it a day.